Okay, let's see. A 1.28 kilogram piece of styrofoam float material being held underwater with a downward force of 328.7 newtons. So we know what we know is we know that the buoyant force minus the weight is equal to 328.7, right? Okay, and we want the density of the styrofoam. We already, by the way, have the mass of the piece of styrofoam, right? Okay, so over here on the side, let's keep track, right? So the density of the styrofoam is going to be the mass of the styrofoam divided by the volume of the styrofoam, right? I'll call that ST, right? Okay, so this is our mass. We've got that, right? All we need is the volume of the styrofoam, and we've got the density, right? This is tricky. Okay, so we got 327 newtons. So let's figure this out. So the buoyant force is going to be the density of the fluid. In this case, it's water, right? We've got that. The fluid times the volume displaced, which in this case is the volume of the styrofoam, right? Times G, right? And then minus the weight. Well, the weight is just that times gravity, right? So the weight is 1.28, right? Times 9.81, right? Is equal to 328.7. So let's just fill these in. Fill in what we know. So 1,000 times the volume of the styrofoam, right? Times 9.81 minus 1.28 times 9.81 equals 328.7. I think we've got it now, right? This is the only thing we don't know. This is exciting. Okay, so 328.7 plus 1.28 times 9.81 is 341.2568, right? Is equal to 1,000 times the volume of the styrofoam times 9.81. I like this problem. Okay, let's see. And now I think I just have to divide this by this and this. Okay, so divided by 9.81 divided by 1,000. And I get that the volume is 0.0347866. So now I'm all set, right? So the density of styrofoam is equal to the mass, which is 1.28 kilograms, right? Divided by 0.0347347.866. And in fact, I'm just going to go 1.28 divided by the number I just got. And I get 36.7957. 36.8 kilograms per cubic meter, right? Which seems like a lot, but remember, a cubic meter is huge, right? Okay. So yeah, that's sort of tough, right? So we had to figure out what the volume of the styrofoam was, right? Maybe you could come up with a more clever way to do it than this. I can't think of a more clever way, but anyway.